I am working with Josh at SCO, and I'm also teaching 3rd grade this year at Oak Grove Elementary School. We've been doing a few of these parent nights, and the request has been to get content specific. So today we thought we would take a walk through the grades 2nd through 5th grade and show how multiplication progresses from 2nd through 5th grade, and what are some of the typical models that you and your students will see through the grade levels. And
Entonces,
go ahead.
go ahead, Emily.
If anybody has anything specific that they want to hear tonight, if you want to type it in the chat, that would be great.
Entonces, Emily nos acompaña con Josh. Ellos son también de la Oficina de Educación del Condado de Sonoma. Ella es también maestra de 3er grado en la escuela elementaria Oak Grove. Y vamos a enfocarnos hoy en el contenido más específico en los niveles de grados de 2º a 5º grado. También vamos a estar preguntando si tienen alguna inquietud en específico que quisiera que nos comunicaran hoy para poder hablar de ello y ojalá contestarle su pregunta. Lo puede poner en el chat en español y yo puedo traducirlo.
And I actually can't see the chat.
Yeah, I'll pay attention to it.
Okay, cool. Thank you.
Yeah, I can't see it either.
Okay. So, hooray for a raise is the subtitle. I tried to make a little light of multiplication, add a little humor, except, there we go. Okay, so we've been starting our evenings with this portrait of a graduate, which is
Emily?
Yeah.
Are we recording?
Yes.
Okay, wanted to make sure.
Great.
Go ahead.
Is something that came out of a partnership between SCO and various organizations in the community, businesses throughout the community, and Josh can speak more to this than I know about it. But these are the main things that the community has said they would like students in Sonoma County to graduate in 12th grade, to be able to join our community businesses with these attributes. And so as school teachers and caretakers, these are things that we need to make sure that we're always have in the back of our minds as we're moving forward with our teaching. Josh, do you want to talk about that at all?
I want to name that, that this was multiple stakeholders, hundreds and hundreds of people across the county worked on this. But also the nice piece was that in our first session, we asked parents what they wanted for their own kids. And there was a really nice connection. And in a lot of ways, parents were asking, this is what I want for my kid too. So I thought that was nice.
Yeah.
Very similar.
Yeah.
Entonces, estas esperanzas y aspiraciones que estamos viendo en pantalla son las cosas que nosotros como padres quisiéramos que nuestros hijos tengan como estudiantes a través de su carrera de estudio. Estas son curiosidad, empatía, comunicación, colaboración, ética y iniciativa. Cientos de personas colaboraron con la Oficina de Educación del Condado de Sonoma para llegar a esta conclusión. Entonces, es algo que queremos compartir con ustedes para que ustedes tengan en mente qué les gustaría que nuestros hijos tengan en ellos a través de los años de sus años académicos.
And so as we walk through multiplication or any math lesson, some of the things that come out really are curiosity and initiative.
Ujú. Y las más importantes que podemos enfocarnos es curiosidad y iniciativa.
Okay. So when we start multiplication with in 2nd grade, we always try to connect it to a context so that we're not just pulling numbers, naked numbers out of thin air. And it's really a great idea for parents to continue, even if you're seeing students working with numbers like 3 times 4. Talk about it in a context. 3 bags of 4 marbles, $3 every day for 4 days, and be thinking about, when am I using multiplication, and talk about that with your students.
Entonces, en segundo grado, cuando ya entramos a comenzar a la práctica de multiplicar, es muy importante tener un buen contexto de la multiplicación. Por ejemplo, es importante estar hablando con nuestros hijos, nuestros estudiantes, cuando tenemos que aplicar la multiplicación. Por ejemplo, cuando tiene que ver algo con la comida, algo con el dinero, también cuando estoy usando, qué herramientas estoy usando para entender algo tan sencillo como 3 por 4. Entonces, siempre tener esa comunicación con nuestros hijos y poder aplicarlo en un contexto todo el tiempo para que tengan mejor entendimiento.
Okay. So here are some typical ways that students are going to begin to see multiplication represented visually. This is typically the equal groups is typically the one that is started with. And the big idea in multiplication is equal groups. So I have 3 groups of 4 things here. And you can see here it's connected to repeated addition. 4 plus 4 plus 4 is 12. So 3 groups of 4 is 12. You may have, some students might see it on a number line. And after we move from equal groups, once they understand the equal groups, we move them to what's called an array model, which looks more like this. And here we have 3 groups of 4. And I'm gonna, arrays are really an important visual model that go all the way from 2nd through really algebra. You'll see kids using arrays in algebra to solve for the distributive property. But here are some various examples. We have 3 times 4, 4 groups of 3, or 3 groups of 4.
Emily, do you mind if we go back to the other slide?
Oh, no, not at all.
Just really quick, and then we can.
There we go. Yeah.
Perfect. Ok. Entonces, aquí nos estamos enfocando, hablando de la multiplicación, en que sean grupos que tengan la misma suma y las diferentes maneras de tener el mismo resultado. Entonces, por ejemplo, comenzamos aquí con estos grupos donde están los círculos, que son 3 círculos y cada uno tiene 4, que nos da la suma de 12. También se puede representar como sumamos 3 veces 4 nos da 12 de nuevo. A veces a este nivel de grado también se puede aplicar con el uso de una línea de números. Y ya avanzando, vamos a estar comenzando a trabajar con lo que se llama arrays. Entonces ahorita podía, ojalá tener más detalle de esto, y ese es algo que se va a estar usando a través de los años escolares hasta el grado 12.
As a teacher of this grade level of 3rd and 4th grade, a lot of times, something to be aware of as a parent, students sometimes have a difficult time translating between equal groups and arrays. They don't always see the equal groups in the array. So that might be something that you can work with your students on.
A veces los estudiantes se les hace difícil ver lo que significa un grupo que tenga la misma suma. Entonces, esto es algo que le podemos apoyar a nuestros hijos. Sería como en tercer grado, en cuarto grado, y como estábamos diciendo, es algo que se aplica a través de los años hasta llegar al álgebra, cuando los estudiantes están trabajando en ello.
And then the other thing that I've even in 5th grade, where students are solving problems using arrays, they sometimes don't realize that the product is the number of squares, the total amount of squares in the array. They sometimes lose sight of that. So that's another, just if you're doing math with your students, something to be aware of.
Y también algo de llevar en mente es, si tenemos un estudiante en quinto grado, recordar que cada cuadro representa el producto y cada producto es el número. Entonces, esto sería para quinto grado, para recordarles, ayudarles a recordar mientras trabajan en ello.
So, once we, I think I skipped a slide, but once we move from basic multiplication facts where we have 3 times 4 as equal groups, we can build on that basic knowledge to do a multiplication problem. This is actually 3 times 16. So we have three groups of 16. And this is actually building on their addition facts from 1st and 2nd grade, where they're building 16 as 10 and 6. And then just they're doing it 3 times. So they would choose one of the arrays to work with first, 3 times 10, and then 3 times 6. It really doesn't matter which order they do it in. And then take so 3 times 10 is 30, 3 times 6 is 18. Those are called partial products. And then it's pretty easy to see if I'm trying to get the total amount of squares in the array, if I know the total amount of blues and the total amount of reds, then all I have to do is add them together. And they should be able to see that and come to that conclusion on their own.
Aquí tenemos otro ejemplo de usando diferentes colores para los cuadritos. Entonces, el problema es de 3 por 16, porque estamos sumando el 10 y el 6. Entonces, esto se llama un producto parcial, porque podemos mirar, no importa la orden, usando cada color a la vez y luego sumando el total, podemos llegar a la conclusión, ellos por su propio esfuerzo, si lo hacemos 3 por 10 y luego 3 por 6 y luego sumar. Entonces, esta representación es diferentes maneras de poder agarrar la respuesta visualmente y también con manualidades.
And usually students start playing around with these larger arrays at the end of 3rd grade, at the second part of 3rd grade and in 4th grade.
Y esto aplica como a finales de tercer grado y entrando a cuarto grado.
Okay. Sorry about that. In this slide, you can see that there are a bunch of squares and kids will draw all those squares, but eventually they're gonna say, oh, I don't wanna do that anymore. So we have, here's 3 times 16, but it's called an open array. So they're not drawing all those squares all the time. And here it is again, 30 plus 18 is 48.
Esto es otra manera más fácil para los estudiantes ya cuando ya quieren dejar de dibujar cada cajita. Entonces, esto sería otro método que sería más fácil, pero para también el mismo proceso.
Okay. And then when students internalize that model where they're doing 1 digit by 2 digits or 1 digit by 3 digits, it's often easy for them to they've used this model for so long that by the time they're in 4th grade and they have to do 2-digit by 2-digit multiplication, all I've had to do is say, so how do you think you would do that? And usually about half the class figures it out.
Ya cuando están entrando al 4º grado, ya se les hace más fácil y más rápido poder contestar un problema de suma de 2 dígitos por 2 dígitos. Entonces, poner el ejemplo que usualmente la mitad de su clase tiene esta rapidez y ese conocimiento cuando es tiempo de este tipo de problemas en 4º grado.
So here's an example of the 2-digit by 2-digit. This is 22 times 15. And most of the kids figure out pretty quickly. You just extend the arrays down here. And when I used to teach the standard algorithm, this would take months for kids to make that jump from a 3-digit by 1-digit to 2-digit by 2-digit. And using the array consistently over the years really helps them internalize this, not only how to do it, but why it works and why you have to multiply 2 times 10 and 2 times 5, or 20 times 10 and 20 times 5, and 2 times 10 and 2 times 5. Go ahead. I'll pause there for a minute.
I just wish we had another word for array, like that I can explain to, you know. But it's okay. I'm trying to explain it else another way. Yeah. Okay. Entonces, esta cajita representa una cajita que está abierta, que se indica que pueden hacer el problema de multiplicar de diferentes maneras. Pueden sumar cajitas para agarrar la respuesta, pero es de indicar el paso por paso, que es más detallado, toma más tiempo, pero es algo que también aplican los estudiantes en 4º grado.
And then just like it's pretty easy for them to go from step to step, pretty soon they're going to say, do I have to draw the array, Mrs. Atkinson? I don't want to do that anymore. And can figure it out by doing this. And a lot of kids will just start doing this and then teach each other how to do this. And then there's oftentimes some direct instruction. This is called the partial product algorithm, which is basically, if you see here, 20 times 10 is 200. Here's the 200. 20 times 5 is 100. Here's the 100. 2 times 10 is 20. There's the 20. 2 times 5 is 10. There's the 10. Add them all up and you get 330. And this is pretty quick. The thing that's nice about this for kids is there's the order. You can add 200 plus 10 plus 100 plus 20. And they're pretty simple numbers, so they're not making a bunch of addition errors. And 20 plus 100 plus 20 plus 10, the kids can do in their heads. So it's a nice way for them to start understanding how to do the 2-digit by 2-digit multiplication.
Ana, miré tu pregunta y ahorita voy a hacerla para ver qué nos dicen. Este método que acaba de describir la maestra también es otra manera donde los estudiantes pueden usar para hacer sus problemas cuando ya no quieren hacer el método de las cajitas. También para ahorrar tiempo. Entonces, los lleva a la misma respuesta y enseñan, demuestran sus pasos y si ahorrar tiempo, ¿por qué aún mejor? ¿Por qué no? Entonces, sí, voy a preguntar la pregunta. There's a question and I'm wondering if we can address it now.
Sure.
So Anna is asking if it's okay for her son to use a different method to respond to his math, if that will cause any issues, or if it's recommended to stick to one method at a time.
So that's a good question, and it's definitely a question that I would recommend asking the teacher because there may be specific reasons why they are working on a specific method. So typically what we're trying to do here is build understanding. And when we stick with this visual, with the array visual for year after year, second grade, third grade, fourth grade, we're building understanding. I'm sorry, what was the child's name again?
She didn't share her name.
Okay.
I would want to ask the grade level though.
Yes, the grade level, and also what I'm always trying to emphasize is it's really about kids understanding the math, and if it isn't making sense to the student, that's where we might explore other ideas.
Entonces, Ana, ¿cuál nivel de grado está tu estudiante?
Está en 5º grado.
5th grade student.
5th grade student. Okay, so in 5th grade, they will transition oftentimes from this partial products to the standard algorithm. And hopefully the teacher is explaining and helping them compare the two algorithms so that the students can see, well, where is the 200 in 22 times 15 in the standard algorithm? When I say the standard algorithm, what I'm talking about is typically the way I was taught when I was going to school, and probably the way you guys were taught. So her son may be learning that in 5th grade right now.
Emily nos comunica que ahora en 5º grado tu hijo debe de estar aprendiendo 2 métodos donde pueden decidir, dependiendo de lo que los maestros prefieran, qué usar con la matemática. Es una transición para ellos en 5º grado y ellos pueden comparar cuál usar a lo que esté pidiendo el maestro. Entonces, se van de esto de las cajitas que se llama el producto parcial a algo estándar, que es de la manera que nosotros cuando fuimos pequeños aprendimos en la escuela. So regresan a ese método. Y también es una manera de que los estudiantes puedan tener y crecer un entendimiento con los números visuales, y también que tengan sentido de las ideas de ellos, cómo están aprendiendo la matemática, y que tengan esa capacidad de cuando algo no tiene sentido es cuando tenemos que buscar ese método que va a poder ayudarnos para hacer nuestro trabajo en matemática.
Something that I would caution is that the way this is designed is, again, to help students understand how multiplication works. And if we jump straight to the traditional algorithm, kids are not thinking about how multiplication works. They're thinking about what steps do I take to get the answer. And that is not the same, that isn't the kind of mathematical thinking that we need to cultivate in students right now. We need to cultivate an understanding of the base 10 system and an understanding of multiplication. And if you go straight to the standard algorithm and just teach that straight, they're missing out on a lot of good, rich mathematical thinking and understanding. Josh, do you want to talk to that a little bit, or?
I'll let Yannette say what you just said.
Oh, right, sorry.
Entonces, una de las razones por qué no enseñan nuestros maestros hoy en día la manera que nosotros aprendimos la matemática es porque quieren que los estudiantes tomen su tiempo y tengan mejor entendimiento, tengan ese sentido claro, tengan esas ideas claras, porque es lo que espera el sistema de estos estudiantes hoy en día al usar la multiplicación.
One thought that I had, Josh, I'm going to interrupt before I give you a chance, is one of the things that I really like about teaching multiplication this way is that kids are also getting a deeper understanding of place value. So that 15 is 10 and 5 and 22 is 20 and 2. And when they're multiplying, they aren't multiplying 2 times 1, which is what they would do in the standard algorithm. The 2 in the 22, the 2 in the tens place. When you're teaching the standard algorithm, kids will say 2 times 1 when what they really mean is 20 times 10, which is a very different thing. So the partial products reinforces number sense and place value.
Este método que están los estudiantes aprendiendo hoy en día se enfoca mucho en el conocimiento del valor proporcional, al igual que el sentido numérico. Como por ejemplo, ya los estudiantes saben que si ven un 15, quiere decir que es un 10 y un 5. Si ven un 12, es un 10 y un 2. Ya cuando están hablando de los problemas que es 20 por 10, saben como más detalladamente cómo resolverlo paso por paso, tomando su tiempo, y ya cuando están más, que se sientan más seguros con este método, ya como por ejemplo ahora en 5º grado, sería más como un repaso para ellos con el nuevo método de la manera que nosotros aprendimos cuando fuimos estudiantes.
I want to really thank her for this question, because this is really the heart of why we wanted to share this, because we know that what we're sharing can be confusing when parents see it at home.
El señor Josh te quiere agradecer por hacer esta pregunta, Ana, porque realmente es el corazón, es el enfoque de por qué hacemos este tipo de entrenamiento, de taller, porque los estudiantes ahora necesitamos poder estar al tanto de los tontos cambios, pero también poder estar teniendo entendimiento y confianza en ello.
And what Emily has shared is, like she shared with place value and other things, it builds not only their ability to answer multiplication problems, but helps them in math that comes later. And so, to be honest, a lot of us, if we were going to do 20 times 15, we have a calculator that we would use. So really, we're using these problems to build understanding.
Tener mejor entendimiento, porque está casi por seguro que si vemos el problema de 22 por 15, nosotros acudiríamos a una calculadora. Entonces, para que los niños puedan sentirse más con ánimo y en confianza de hacer este tipo de problemas mentalmente y visualmente, esto es una de las maneras por qué se enfoca ahora en esta área la matemática, que tengan esa habilidad, esa capacidad.
We like to say that answers are important, but not sufficient.
Las respuestas son importantes, pero no es suficiente en términos de matemática.
Thank you. Okay. So when students get a grasp on this, they get really familiar with using arrays for all kinds of multiplication. Like I said, in 5th grade, they will start understanding how the standard algorithm works from this. It builds on it, but you guys all know that. So we didn't think we needed to explain that. And so once they've worked now at this point in 2nd grade, 3rd grade, 4th grade with whole number multiplication, and in 5th grade they go into multiplication with whole numbers and fractions, whole numbers and decimals, and fractions with fractions. Well, it's the same idea. So here we have 3/4 times 5. And what happens here now is we have 5 boxes, and each box is split into 4 groups, or not 4 groups, into fourths, sorry. And each box is shaded 3. And so here we have, this is kind of nice because you can see 5 groups of 3/4. And you can also see 3/4 of 5. And then the kids can count up. Here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, etc., bringing us to 15/4. And they pretty quickly get, I don't want to count all those, but I could start counting by 3s. Oh, I just multiply 3 times 5. So they actually start internalizing why you just do 3 times 5 is 15. They start internalizing this algorithm before it's even taught to them when they're using arrays like this, because nobody wants to sit there and count all these fourths. And they're familiar with multiplication at that point. Oh, I know what I was going to say is back when I was in school, this was not an acceptable answer, 15/4, because it was an improper fraction. Nowadays, 15/4 is an acceptable answer.
Entonces, aquí está otra manera que a través de los años nuestros estudiantes están aprendiendo. Ya como tienen diferentes áreas de matemática que han cubierto a través de sus años de 2º a 5º grado, están multiplicando números enteros y luego están llegando a lo que son las fracciones y los decimales. Entonces, antes no los maestros no podían aceptar una respuesta de aquí de una fracción que era 15 sobre 4. Ahora esto es totalmente aceptable.
Okay.
Y los niños pueden ver visualmente que les ayuda a tener una respuesta y a veces ahorrar tiempo en cómo resolverla, porque ya lo visual les es otra herramienta a su favor de ellos.
Okay. And then again, we can work with, oh, did I move the wrong way? Yep. It's the same idea with multiplying by decimals. Here we have 2 times 1 and 3/10. And you probably have seen these. They're called hundreds blocks. What the thing to keep in mind here is that in the younger grades, this blue block here is 100. When we start working with decimals, the blue block represents 1, and the squares inside are hundreds. So that's a big shift for kids, understanding what the 1 is. But this is, so 2, 1, 2. And then these 10s that in the primary grades, the yellow long stick things are called 10s. But when we use them for decimals, they're tenths. So 10 of them would equal the whole. So here we have 1 and 1, 2, 3/10. And if we wanted to count every single one of the squares, we would find the product to 2 times 1 and 3/10, which I'm not going to do off the top of my head, and we didn't put the product. But this would be how we would model it. It's the same idea.
Aquí miramos los bloques de azules que representan cuando nosotros estamos aprendiendo 100. Hoy en día representan lo que es uno entero. Por ejemplo, cuando están multiplicando fracciones. Entonces nos está diciendo que los pasos que tenemos que tomar para qué representa el azul y qué representa el amarillo, que el amarillo que es 10 y el azul es un 1 completo, entero, cuando estamos hablando de decimales.
And now that I've said that, it's obviously 1 2 wholes and 6/10.
Entonces aquí sería 2 enteros porque son 2 azules y 6 dieces porque son 6 amarillos y cada uno representa 10. Ojalá esto tenga sentido, Ana. Esto es algo complicado porque es como otro idioma la matemática.
Okay. So I do have a video that explains a fraction by a fraction, and we do have a little bit of time, but it isn't translated. So I might let's just see.
Maybe I can sum it up.
Okay. And the
Order to
visual is
properly
nice.
model the multiplication of these two fractions. So if we look at our fraction 1/3 here, and then we look at 1/3 and then we pay attention to our model here, we can see that our model has actually been divided into thirds. If we look at it from a vertical perspective. So there's actually 1, 2, 3 sections that have been divided into this this whole here. So we're going to look at our 1/3, and we're going to note that we have 3 sections that have been divided into this whole, and we're going to just shade 1/3 of those 3 sections. So I'm just going to shade in 1/3, so just one of those 3 sections. And so now we have 1/3. And so now we have to pay attention to this 3/4 over here. And let's go ahead and make that 3/4. We're going to circle it in red. How about that? So now we're going to need to find 3/4 of the 1/3. So if we look at our whole, and remember that this whole quadrilateral here is representing 1. And when we looked at it from a vertical perspective, we saw there were 3 columns, and we shaded one of those columns in to represent 1/3. But now we're going to take a look at these horizontal rows here. And we see that those rows have divided the whole into 4 sections. And so if we just focus on the 1/3 here, we just focus on the 1/3, I'm going to find 3/4 of that 1/3. Well, that 1/3 has been divided into 1, 2, 3, 4 equal pieces. And so 3/4 of that 1/3 would just be 3 of those pieces. So I'm going to color in three of my 4ths here. And you guys will be able to do a much better job on a piece of paper with some crayons or some colored pencils. But I hope you get the idea. So I found 3/4 of 1/3. And so in finding the product of 3/4 times 1/3, I look at my model and I say, all right, well, how many pieces have been colored over twice? I have 3 pieces that have been colored over twice. So that's going to be the numerator of my product. And then the denominator is going to be the total number of sections or pieces of my whole. So I actually have 12 total pieces or sections. So that's going to be the denominator. So the answer, or the product of 3/4 times 1/3, is 3/12. And hopefully the model kind of proves why 3/4 times 1/3 really is 3/12.
I would just cross multiply. I just that.
So yes, this is not an efficient way to get an answer, but that isn't what we're trying to accomplish here.
Entonces aquí estuvo un ejemplo que ya ves cuántos pasos tomó para hacer una respuesta de estas fracciones, y ojalá el modelo y usando diferentes colores puede ayudar a nuestros estudiantes a hacer paso por paso, tener buen entendimiento y llegar a la respuesta correcta.
Okay. And we are coming to the end of our time. Are there any questions or thoughts or?
¿Alguna pregunta, alguna inquietud por ahora? Aprendí que el producto quiere decir respuesta, entonces algo nuevo cada día usando este tipo de modelo. ¿Alguna pregunta, Ana?
No, pues yo pregunté eso, que si podía cambiar el método, porque uno, como aprendió de otra manera, les quiere enseñar, pero los niños se confunden a veces. Entonces, ahí es donde digo, lo puede cambiar, pero si lo cambia y la maestra le explica el método de ella, se va a confundir. Entonces,
sí,
difícil.
Sí, y luego ya todos nos frustramos en esos casos, ¿verdad? Sí, entonces les sugerimos que pregunte al maestro o a la maestra y ya ellos pueden decir, está bien, puedes hacerlo de este método o no, quiero que lo estés haciendo como yo te estoy enseñando.
Okay.
Yeah, Anna shares with us that it's just difficult to support at home when we were taught one way and now they're learning a different way. So then it becomes a frustrated situation. And I just reminded, maybe it would be good to ask our current teacher what they prefer on how we, respond to our math.
And that, Emily, I'm going to share the website.
Yeah.
And Yannette, that we have one of the questions, I meant to say this earlier when having the conversation, is a question she can always ask her son is, what makes sense to you?
Y algo que también puedas hacer, Ana, es siempre decirle a tu hijo, preguntarle, ¿qué tiene más sentido para ti? ¿Qué método tiene más sentido para ti? Y ya de allí poder guiarlo.
And tell her that I put the link to the website in the chat.
Okay. Puso el enlace al sitio web en el chat. No sé si pudiste mirarlo. Donde nos da más ideas y herramientas para poder apoyar a nuestros hijos.
And on the first page, there are more questions that she can ask to help.
Esto también aquí está en español y es para hacer más preguntas, para poder apoyar. Está en la
Oh.
primera página y este es el sitio web.
¿Ese sitio lo puedo abrir directamente de aquí o se va a borrar cuando acabe el Zoom meeting? ¿O cómo?
Will she still have access to the link after our meeting tonight, or does she need?
If she puts her email in the chat, I will email it right to her.
Oh,
Perfect.
okay.
Sí, por favor, puedes darnos tu correo electrónico y el señor Josh te lo va a enviar después de esta reunión.
Oh, okay. ¿Lo puedo dar ahorita? ¿O en el
Sí,
chat?
por favor. Sí, en el chat lo puedes poner, por favor.
Oh,
Y él te lo va a
Ajá.
enviar acabando la reunión.
okay.
And there are plenty of other resources in here. A whole section for Spanish. And we've also added some multiplication games here that are fun to play.
Hay más opciones para uso de matemática. También con la multiplicación están en español y también son algunos juegos para hacerlo divertido, pero también que tengan este resultado académico.
Oh, está bien. Gracias.
Sí, recursos en español.
Es que mi niño me dice que cuando está en la escuela a veces el método como a veces lo siente muy largo y se confunde.
Sí,
Entonces, eso es lo que a veces veo como que a veces eso lo hace que ya no quiera interesarse en estar haciendo como más. Siento como que se confunde un poquito.
sí se
Entonces, sí, se desanima. Entonces, por eso yo a veces trato de ayudarle y a veces veo que lo entiende más rápido, pero el problema es que no sé qué opina la maestra. Necesito hablar con ella.
Ok. Sí, eso sería un buen paso para hacer. Y también, por favor, te pido tiempo para poder ver estos recursos y ojalá tú con tu estudiante, tu hijo en este caso, puedan llegar a un acuerdo en qué enfocarse, que lo va a hacer para él más divertido y que no se desanime, que se motive más,
Okay.
al contrario, sí. Yeah, Anna shares with us that it's frustrating when she helps her son one way and she's able to pick it up faster, but it's a good idea that now she will refer to their teacher and ask what they would prefer, because too many steps are confusing her son and too many steps are making her son feel overwhelmed. So that he's losing interest in moving forward in terms of math because it becomes challenging.
At this point, I would bring that to the teacher's attention, and also he needs to be able to not just follow steps, but understand what it is and why it is that he's doing what he's doing. And again, what sense is he making out of the multiplication?
Sí, es muy importante que los estudiantes, en este caso tu hijo, tenga sentido de lo que está haciendo, que no solamente es seguir un paso en la matemática, pero tener un buen entendimiento, tener un buen sentido de qué está haciendo y por qué lo está haciendo de esa manera. Entonces, claro que te recomendamos acudir a la maestra en este caso para ver qué sugiere. Sí.
Okay.
Yeah.
Puse el correo, sí salió.
Josh, were you able to see the correct email
No, I
address?
don't see it. Did it come just to you?
Sería nomás a mí.
Creo lo puse a Janet.
Oh, send it to me. Lo podemos poner a Josh. Pero sabes, okay, I see it. Okay. Yeah.
Can you copy and paste it and put it in?
Sure.
Sure.
Perfect. So yo se lo puedo enviar, Ana.
Okay. Gracias.
Gracias. Sí.
All right, folks. Thank you so much for coming tonight.
Muchísimas gracias por asistir hoy. Ojalá haya sido de alguna ayuda.
Yeah. Gracias a ustedes por su tiempo. De verdad lo aprecio mucho.
Anna is very grateful for her time and she says thank you.